in the question, we can directly find magnitude of A because this is an exterior angle. This should be equals to interior's opposite angle. Okay, interior's opposite angle. That means A plus 65. A plus 65 degrees equals to 120 degrees. So A should be 120 minus 65. So that will give you A as 55 degrees. Okay, A as 55 degrees. If okay, I'll indicate the magnitude of A here. Okay, we found our A as 55 degrees. 55. Okay, here you can see we studied one theorem in our grade 10. This is a chord. Okay, this is a chord. This chord is creating two triangles in circumference. Two triangles in circumference. Okay, the similar chord, same chord creating two triangles in the circumference. So these two angles should be same with each other. If this one is 65, D also should be 65. Okay, D also should be 65. Try to remind that theorem. But it says by using a same chord, when we draw two triangles in circumference of the circle, the angles which is created by those triangles are same. So if it is 65, the D also should be 65. Okay. Then after let's find for E, angle for E. So here 80, this is 65. We found it as 65 now. So 80 plus 65 plus E equals to 180 because these are adjacent angles in a straight line. So summation of them, that will give you 180. So 80 plus 65, 145. From 180, when we subtract 145. So our E should be 35 degrees here. E should be 35 degrees. We found our magnitude for E as 35. Okay, E as 35. Similarly, remaining we need to find B and C. B and C. Okay, to find the C, look at this picture. This is a chord. Okay, this is a chord. This chord is creating two triangles in the circumference of the circle. Okay, this is a chord. This is the chord. Okay, Alma. Okay, this is your chord. This chord is creating two triangles. One and two. Two triangles in the circumference of the circle. So their angles. Their angles created are same. So if A is 55, C also should be 55. A is 55, C also should be 55 degrees. Should be 55 degrees. And remaining one only we have to find for magnitude B. Okay, magnitude B. Okay, for that, let's use exterior angle theorem. If this is 80, okay, exterior angle in a cyclic quadrilateral is 80. Interior's opposite angle summation also 80. Sorry, interior's opposite angles also same. Opposite angle also same. If it is 80, here B plus C should be 80. We already found our C as 55 now. So B plus 55 should be equals to 80 degrees. I'll repeat once more. This is an exterior angle. Okay, this is an exterior angle. This should be equals to interior's opposite angle. That is B plus C. B plus C. We found our C as 55. That's why I substituted C as 55. So B should be 80 minus 55. 80 minus 55. That will give you B as 25 degrees. B as 25 degrees. Okay. This is a complex question. Okay. There are too many magnitudes. We have to find totally 5 magnitudes now. So we have to use different kinds of theorem to incorporate this diagram. Okay. First of all, what we did. Okay. Start. Here this is our exterior angle. This should be interior's opposite angle. So summation of A plus 65 equals to 120. Likewise, we found A as 55. Okay. Then we found D as 65. That one also direct one. This is a chord. this code is creating two triangles in the circumference of the circle. If this is 65, the D also should be 65. If you are not clear with this, just put a bracket and indicate what theorem we used here. Okay, what theorem we used here. Sometimes you will not understand when you look at the question again. That's why if you want, you can note as much as you need. Okay, then this one. Okay, here also this is a code. This is 65, this is 65 though. So let's use, this is a straight line. No? Summation of all these adjacent angles should be 180. 80 plus E plus 65 equals to 180. Likewise, we found our E as 65. Okay, E as 65. Then here also this is a code. Code is creating two triangles in the circumference of the circle. So if A is 55, C also should be 55. Then exterior angle 80 degrees, that should be equals to interior's opposite angle. So that is B plus C. C is 55. Likewise, we solve to find our B as 25 here. That's all from this question.